All right, hopefully everyone's doing well out there, but this little video is designed to give a little bit more help with scientific notation. I already have one on the YouTube channel, but hopefully this one can provide a little bit more help for those of you that might be having trouble. On this first screen here, just so that you're aware of what this video will encompass here, it includes writing numbers in scientific notation. So if we take a number like 26 million and you're asked to convert that or write that in scientific notation, we're going to talk just a little bit about that. Taking a decimal number like 0.00064 and also writing that in scientific notation, as well as the second part that we'll cover is what do you do when you have an answer that's in scientific notation but it's not in what's called proper scientific notation. In this case we might have 0.31 times 10 to the fifth or 36.2 times 10 to the negative 4, and both of those we'll talk a little bit about why they're not in proper form and how we go about getting those in proper form. So first of all, let's take the number 26 million and let's look at writing that in scientific notation. Proper form says that there should be one non-zero digit to the left of the decimal point. So if we're going to do this properly, the non-zero digit is the 2 here. The decimal point needs to go right in that spot, right between the 2 and the 6. So we need to move that decimal point over, and in this case, the decimal point, even though it's not shown, remember, is right now being or is sitting right at the end of those zeros. So we need to move that decimal spot to the left, and we need to write that so it becomes the number 2.6. Scientific notation says that's going to be times 10, and the question is how many spots is that decimal spot moved or decimal point moved over? And in this case, you could simply count them out if you wanted to. You could just start here and say there's 1, 2, 3, 4, 5, 6, and 7 to get this to that spot. Therefore, the answer would be 2.6 times 10 to the 7th. Remember, this is a very large number, 26 million. 10 to the 7th power turns out to be a very large number as well. So we would be taking 2.6 times a very large number. It's just an easier way maybe of writing 26 million, obviously called scientific notation. So it's going to look like that, and that would be your answer, 2.6 times 10 to the 7th power. Now if we take on the other side a decimal number like 0.00064, remember the rule is that we want to have one non-zero digit to the left of the decimal point. So if I find the first non-zero digit as I move from left to right, first non-zero digit is the 6. I would like the decimal point to end up right there between the 6 and the 4. So I only have one non-zero digit to the left of the decimal point. So if I place it there, I know my number is 6.4. The question is then, how many times has the decimal point moved? And in this case, the decimal point is visible. Again, I can count it. 1, 2, 3. It's moved 4 times. But because I moved to the right, because I have a very small number, I need to have a negative in this case. And remember from what we've talked about with negative exponents, 10 to the negative 4 is really 10 to the 4th, which would be the number 10,000. But the negative means that we need the reciprocal of that, so it becomes 1 over 10,000. So this 10 to the minus 4 really is this fraction, 1 over 10,000. And if you think about it, 6.4 times 10 to the negative 4, or 6.4 times this tiny fraction should give us a very small decimal. So making sense that when we have a large number like 26 million, our exponent is going to be positive. And when we have a small number like 0.00064, we're going to have a negative exponent in this case. So hopefully that makes sense in terms of writing numbers in scientific notation. The next part is writing them in proper form in scientific notation. In this case, we're going to have 0.31 times, and I guess our original problem was times 10 to the 5th. Now, if you think about what I said in the last two problems, proper form for scientific notation says that the decimal point should be located right there, between the 3 and the 1. Why should it be there? Remember, there should be one non-zero digit to the left of the decimal point. So I need to make sure that that decimal point moves over. I see a lot of students that have trouble trying to decide, when I move it one spot, does this go down 1 or does this go up 1? And here's what I would say. Is think about this. If you take 0.31 times 10 to the 5th, multiplying by 10 to the 5th, that's a pretty big number. In fact, that's going to be the number 100,000. If you take 0.31 times 100,000, that's going to move the decimal 5 spots to the right. So if you wanted to, Going past the 3 is 1 spot, going past the 1 is 2, 3, 4, 5. I could take the number 0.31 times 10 to the 5th and I could write it in our normal standard form, which becomes the number 31,000. So I've taken this number out of scientific notation. Now I can go ahead and put it back in scientific notation. The decimal point should end up right there. Remember, one non-zero digit to the left, so it's going to be the number 3.1 times, and now count it out when you come back into scientific notation. The decimal point is here, so we're 1, 2, 3, and it's only 4 spots to get back. Now that might be the long way to get to the answer, because if you're looking at the original problem and saying the exponent was 5 and it's 4, anytime you move the decimal point to the right, you're going to end up subtracting. Anytime you move the decimal point to the left, you're going to end up adding. So in this case, because I wasn't sure, I took the number, the scientific notation number, out of scientific notation, and then I put it back into proper form, and that helped me decide that 10 to the 5th should really become then 10 to the 4th power. Hopefully that makes sense. The last one is a similar situation. This time it's 36.2 times 10 to the negative 4. And again, I know that the decimal point, based on what we've talked about here, the decimal point should go between the 3 and the 6, because we're supposed to have one non-zero digit to the left, not 2 as we have in this case. Because this is a negative 4, I'm going to move the decimal 4 spots to the left, going past the 6, going past the 3, and then I'm going to need 2 zeros. So I would have 0.00362, moving that decimal 4 spots to the left. Now if I put it back in scientific notation, proper form says that it would go right there, so I would have 3.62 times 10, and I would move 1, 2, 3 spots, and we're talking about negative 3 in this case. So notice in this case I moved from negative 4 to negative 3. That should put it back in proper form. I think I have a screen here that just shows when we move the decimal point to the left, we need to make sure we add 1 for every spot we move. When we move the decimal point to the right, we need to make sure we subtract. So if this was the case, I had to move the decimal 1 spot to the left, and the rule on that page said that I should add. Well, if I take negative 4 and I add 1, I'm at negative 3. Remember, adding 1 moves me to the right on a number line, so it's going to move this from negative 4 to negative 3. And in the case right here, because I was moving to the right, the rule that I had on that screen says that I should subtract 1, so 5 subtract 1 turns out to be a 4. And hopefully that makes sense. Moving the decimal to the left means add 1 at a time for every spot I move, and moving the decimal to the right means I subtract. I hope this helps. Certainly reach out, ask one of your peers, or ask a teacher if you still have questions.